We'll now look at solving rational equations. So first, what exactly is a rational equation? Well, rational is just the math word for fraction. So it's essentially just equations with fractions. However, we're going to make them slightly more complicated and be able to put our variables on the denominator instead of just on the top. So let's look at an example. Here's one example, 1 over n minus 8 minus 1 equal to 7 over n minus 8. And this can be very off-putting at first. I mean, no one really likes fractions, and then to put them inside of an equation makes it even worse. Well, these actually really aren't too difficult. If you think back whenever you first learned about solving equations, you probably learned to clear your fractions anyway when you're dealing with linear equations. And we did that by just multiplying by the denominator, so that's all we're going to do here. Let's multiply both sides by the denominator, n minus 8. When I multiply the first thing by n minus 8, the n minus 8's cancel and I'm left with just 1. Negative 1 times n minus 8, and then on the right-hand side, 7 over n minus 8 times n minus 8. Once again, that denominator is going to cancel, and I'm just left with 7. And now I have something linear that we know how to solve. So this is the idea of rational equations. We want to clear the denominators. We're going to multiply by whatever's on a denominator to get rid of the fractions to make this problem easier. We have negative n plus 8 equal to 7. Don't forget to actually distribute your negative sign. We know 8 plus 1 is 9. I can now subtract 9 from both sides. That gives me 7 minus 9 is negative 2. And multiplying by negative 1 would give me that n is equal to 2. And when we're dealing with these type of equations, it's very important to check your answers. The main thing we want to do is make sure we don't put 0 on the bottom of a fraction, because we could do that. But we know that that's actually really bad in mathematics. So let's double check. This would be 1 over negative 6 minus 1 equal to 7 over negative 6. So I don't see any contradictions with 0 on the bottom of a fraction here, so it's safe to assume that we were right and this is the correct answer. So this one was easy because all of our denominators were the same, so let's start making it a little more complicated. Our next example, 1 over 6x squared equal to 1 over 2x plus 7 over 6x squared. Well, like we did before, we want to multiply by something to get rid of the denominators. In the last example, I just multiplied by whatever was on the denominator. But this time we have different denominators, so is that going to affect things, and if so, how? Well, we can see that we do have x's on denominators, and so we're probably going to want to multiply by x. However, multiplying by x isn't enough because we notice in the first fraction and the third fraction we would only be canceling one of the x's in the denominator. So let's do x squared. And that will definitely cancel all the x's in the denominator. Well, what about the numbers? Well, we'll just use 6 because 6 is going to cancel both the 6's and the 2's. So we are still multiplying by one of the denominators, just not both of them, because one of them actually divides into the other two. So that makes this a little bit easier. My first fraction, the 6x squareds, are going to cancel. I'm just left with 1. The second one's a little more complicated, so let's skip it for just a second and go to the third one, where the 6x squareds cancel and I'm left with 7. So the first and the third were a little bit easier because my denominators are the same. So let's try the middle one now. Well, as some side work, 1 over 2x times 6x squared. I can see that one of my x's cancel, but not both. And I also know that the 2 cancels. 6 divided by 2 is 3. So I'm really left with a 3x. From there we can solve pretty easily. Subtract 7 from both sides and divide by 3. Gives me that x is negative 2. And we can double check this and see that we never get a 0 on the bottom of a fraction, so we should be okay here. So Our first example, all the denominators were the same, and our second example, while they weren't the same, they were close enough that we could just use one of them. So what happens when it's a little bit more complicated? Well, we'll deal with that fairly soon in the next video, but for now, let's just take advantage of the fact that these were very simple. And while they may not be the most simple problems to solve, overall, if we can figure out what to multiply by, that it turned into something that we know how to solve very easily. So really, the only thing complicated about this is that first step in figuring out exactly what we need to multiply by to make the fractions disappear.